Okay, yes guys, good morning. I hope you are able to view my screen now, right? So now in our today's session, we'll be going to discuss about a very important, okay, tool over here guys. So let me first, okay, open our Venn diagram. And today, okay, let me, okay, yes guys. So today we'll be going to discuss about Docker over here guys. Okay, and one of the very popular, okay, things you have Docker about over here are containers. Okay, so what are Docker containers? We are going to see over here now. So Docker is actually a name of a company guys. Okay, but people refer containers as Dockers mostly. Okay, so Docker is actually a name of a company, okay, which has given containers for us. So normally people refer to containers as Docker only mostly. Okay, so not only containers, Docker has a lot of other things also to its products. We have Docker Swarm, okay, we have Docker Desktop, we have Docker World. Okay, so if I take you guys to the official website of Docker, so there we'll be going to see, okay, that, okay, so it has a lot of other products also to its list. Over here you can see, okay, so these are the list of products what Docker has, and most important and most popular among them is containers over here. Okay, right. So now going to our diagram, so let us understand what are containers over here guys. Okay, so to understand containers, I will compare your containers with your virtual machines over here guys. Okay, suppose this is your virtual machine. Okay, we have created virtual machines, right? Windows virtual machines and Linux virtual machines, right? So let us assume that this is your virtual machine. Okay, and let me compare a virtual machine with a container, and this is a container guys. This is your container. Okay, so when I am comparing virtual machine to a container over here, okay, so from a diagram you come to know one thing over here is virtual machine is a machine and container is also a machine only guys. Both are machines only over here. So container is a machine only. Virtual machine is also a machine and container is also a machine. Container is not a database. Container is not a network, or container is not a storage. Container is a machine only. Okay. So virtual machine is a big machine and container is a lightweight machine. You can say that container is our small machine. Container is a lightweight machine and virtual machine is a big machine. Okay. Now for creating a container, okay, so for creating a container I need virtual machine. So you will create containers inside virtual machine only guys. So it is like a machine inside a machine. Okay, so container is like a machine inside a machine. So inside your VM only you are going to create your containers. So inside our VM we will be going to create our containers over here. Right, now going to our next difference over here. Okay, so when you are creating a virtual machine guys, okay, how much RAM and hard disk you people are selecting? So we can create virtual machine with 1 GB RAM also. You can start with 1 GB RAM on Azure cloud. You can create your virtual machines from 1 GB RAM, okay, and you can take the hard disk of about 120 GB will be your hard disk size. Okay, so 1 GB is your RAM size, 120 GB is your hard disk size. Normally, we can get up to 8 GB of RAM in our free account for our virtual machines, right? So now if you see the same thing for a container, okay, if I show you guys that how much RAM and hard disk your container will use over here, you know, if I give a RAM over here, I'll be using the RAM of about 100 MB guys over here. 100 MB will be my RAM size. Compared to your virtual machine, this is just a 10% of that what you are using over here. Actually, I don't need 100 MB also, but still I am giving 100 MB as my RAM size. It is just 10% of what your virtual machine is using over here, right? And in terms of hard disk, if I write over here, you will be amazed to know, okay, That hard disk size for my container or memory size, I'll take only 200 MB guys. 100 MB is my RAM size and 200 MB, I'm in MBs only. I'm not in GBs, I'm in MBs. So 200 MB is my hard disk size. Compared to virtual machines, it is not even 1%. Right? We are taking 120 GB. So where is 120 GB compared to your 200 MB? Right? So if you take 1 GB, which is 1000 MB, right? So it is 1000 times more than this working. Okay. Now let me tell you one more interesting thing. Your container is running with just 100 MB and 200 MB, right? It uses very less CPU and less memory, but this container will be faster than your virtual machine. If you compare the speed and performance over here with comparison to your virtual machine, your container will have more speed compared to your virtual machine over here, guys. In terms of speed and in terms of performing the operations, your container will have more speed compared to your virtual machines over here. Right? Now the question is, even though it is utilizing so much less CPU and so much less memory, how come it is faster than my virtual machine? Okay, because it is using less memory, less CPU. It is way smaller than your virtual machine. Still, it is way faster than compared to your virtual machine. So now let me tell you the reasons that why container is so much fast in your environment. Okay, the first reason over here is, if you see in your virtual machine, guys, you will have complete operating system. Your virtual machine comes with complete operating system, right? So when you are creating your virtual machine, either Linux or Windows, you will get complete operating system over there on that machine, right? So for Windows, minimum 30 to 40 GB will be occupied. For Linux, at least 10 GB will be occupied by operating system only. You have operating system files, operating system libraries, operating system runtime files will be there on your virtual machine. But you know what container does over here? Container will not have a complete operating system. Container will not use a complete operating system over here. Actually, container will doesn't have an operating system of its own. It uses the operating system from the virtual machine it is running on. So it will use the operating system from this virtual machine. So technically we call it as our host machine. So it will use the OS files or operating system files from this host machine over here. So it doesn't have its own operating system over here. That is the reason it doesn't need more RAM, it doesn't need more memory, and it is using the operating system from the host machine. Okay, so on whichever virtual machine you have created the container, from that virtual machine it will use the operating system. So whatever operating system files it needs, it uses your operating system files from your host machine only. The machine on which you are creating the containers, on that machine it will consume the operating system files. So that is the reason why it is so fast and why it is using so less memory. It is not running its own operating system. Okay, and still what it will do over here is, okay, let me tell you this thing first. For creating your virtual machines, guys, okay, for creating your virtual machines, what do you need? You need image. Actually, with the help of image you will select what type of machine you want, right? So with the help of image, okay, you will select what type of machine you want. Suppose you select a Linux image, it will create a Linux machine. If you select a Windows image, it will create a Windows virtual machine, right? So when you are creating the virtual machine, image option is there, right? From that image you are selecting the operating system of this machine, right? So image is important over here. With the help of image you are creating your virtual machines. So over here for the containers also, when you are creating the containers, for creating containers also you need images, guys. We call these images as container images. Okay, we call these images as our container images. Okay, so both are machines, so both need images to get created. Okay, Right, very good. Now, what type of images you need over here? Okay, so container needs these kind of images, guys. For example, if you want to create a Java container, you have to select a Java image, and then a Java container will get created, and Java container will run only Java only for you guys. It will not run any other thing apart from Java, but it will run Java faster than your virtual machine. It will run that one particular set or package or application which you want to run inside the container, but it will run that particular package in your container faster than virtual machine. If you want Python inside your container, select Python image. It will create a Python container. So in the same way, what you are doing in virtual machine, you are selecting Linux image, Linux machine getting created, right? So over here you choose Java image, Java container will get created. You select Python image, Python container will get created. Or you select MySQL image, MySQL container will get created. So whichever container you want, you can create. You have to select the image over here. So according to that image, you will have that one particular container. Okay. Now, so going back to your virtual machines, for creating virtual machines, you are selecting images over here, right? So if you go to home, if I go to virtual machines, and if I click on create, okay, so over here you see you have list of images over here, right? You have Windows image, you have Linux image, okay? All these are the list of images which you have with you, right? So where are all these images? On your Azure dashboard only you have all those images, right? So then where are container images? Virtual machine images are over here only. We can see the list of images are over here. Then where are container images? So for container images, Docker has given a one separate repository for you guys. We call it as Docker Hub. Okay. So Docker Hub is a place where you have your container images. All your container images will be inside your Docker Hub. It will not be available on your Azure dashboard, guys. On your Azure dashboard, you will not find any container images. Your container images will be available on Docker Hub. Okay. So over here, whatever image you want, you can search. For example, if you want a Java image, you see, you search for Java over here, it will give you the Java image. And these are the official Docker images, which means these are verified images for us. Okay, verified officially. So you can use these images over here, right? So not only Java, if you want Python image, search for Python and it will give you the Python image, official Python image. Okay, and if you want MySQL container, search for MySQL image, it will give you a MySQL image. So whatever images you want, okay, you can get it from Docker Hub. This is our official registry where you have all your container images. Okay, right now going to our next thing over here. Okay, so as I told you guys, whatever you want to create as a container, you can create. And if you are creating Java container, it will run Java faster than our virtual machine, right? Fine. Now coming to our next important thing over here. So let me tell you the real-time implementation of containers. That where are you actually using containers in real time? Okay. So if I take a one more new picture over here, okay. So let me start with an example, guys. Okay, suppose you have a big server over here. Okay, you have taken a very big server. Now on this server, what I want to do is I want to do, okay, my credit card transaction on this server, guys. Okay, I want to do a credit card transaction on my server. So in a older way of working, or in a, okay, previous generation method, what we used to do is, okay, suppose your programmer is writing your program, might be in Java or might be in JSP or might be JavaScript or Python, let him write in whichever program he wants. Okay, not an issue at all. So what they used to do is, you have one big server over here, right? And if you want to do the credit card transactions, they used to write a program. Okay, And in which way they used to write the program over here? Okay, let me give the logics over here, right? So they used to start, and the first logic they will write to check your credit card number. Okay, so once you have done with your first logic, you will be having your second logic to check the CVV of your card. Okay, to check the CVV number, right? And the next logic they might be running over here to check the balance. Okay, so if you have the balance, it will get debited. And the next logic, okay, debit amount. Okay, and the next and the final logic over here, we can run it as a feedback. Okay, for our transaction that which we were running over here, right? So we used to have one big server. We used to run our program like this. So each logic, they used to write a logic over here for each, okay, set, and we used to run the program, right? So first logic executed, it will go to second logic, it will get executed, it will go to third logic. Okay, so in the same incremental fashion it will work, right? Very good, understandable. But the transactions which we used to do over here in previous generation, we used to face a lot of issues over here, guys. Okay, in the previous generation transactions, if you used to see, first of all, it used to take a lot of time, and second thing, sometimes amount used to get debited, but it should not reflected on the other side. Okay, transaction failures were there, so a lot of issues were there in this kind of a setup, but still we used to use it because there was no other way. And this kind of maintaining and managing your architecture is called as macro setup, where you're writing one big program executing in one big server over here like this, right? Older way of working. Now what is happening over here in the industry, okay, in the right now in the industry, what we are doing is we are taking a server. No doubt we are taking one server, and in this server what we are doing is we are creating containers over here, guys. Okay, suppose I have container 1, container 2, container 3, okay, container 4, okay, and my container 5, right? And now what is happening over here is whatever logic they have written over here, right, for checking the credit card number and all, I'm not writing it in a single program. I'm not writing that logics in a single program over here. What I'm doing over here is I'm writing this logics inside a container. Okay, so the first container will check my credit card number. First container, it will check my credit card number, and it will not do any other operations apart from checking your credit card number. So your first container, it will not check CVV. It will only check the credit card number only. But it will check the credit card number very, very fast, because its behavior, its performance is very, very fast, right? It will do one operation, but that one operation it will be do in a super speed over here, right? So first container will check your credit card number, right? And second container will check the CVV. Okay, third container it will check the balance. Okay, fourth container it will debit the amount for you. Okay, and finally you have fifth container where you will be doing your feedback, for example. Okay, now each container is not dependent on each other over here, guys. No container is dependent on each other, and every container will do that one job only, but it will do that job very, very fast. It will immediately check the number, again it will sit idle. It will ask you to please give one more number, right? Within fraction of seconds it will do its task. Okay, and if you see the same example over here, right now the same thing is being utilized, your containers, and the same method is being utilized by your, what, you are utilizing GPay and PhonePe, right? You are using GPay and PhonePe, they are running on containers only. Your Google Pay, your PhonePe, they are running on containers only. So I no need to tell about speed now. If you compare with your previous transactions, you people already know that how fast your GPay and PhonePe will work. How come your PhonePe and GPay working so fast? Because of containers only. So first container will check the phone number. Second container will verify the phone number. It will give you the name of the receiver at the other end. Then if you have the balance, it will debit the balance, and again it will give you the transaction success message, right? So everything is taken care by container over here. So the transactions which used to do to your previous method to this method, that is the reason why they are so fast over here. And failure rate is also very low compared to previous method of transactions. That is the reason why we are going for containers. In terms of CPU and memory usage, they will use less. Still, okay, for checking your credit card number, it will still use 100 MB RAM and 200 MB hard disk only. It will use less CPU, less memory, but it will perform faster than that big virtual machine. Right? So these kind of transactions, what you are doing over here is called as micro setup, guys. So you also call them as microservices. So basically we create containers for running our microservices. Now, what is our job as a DevOps engineer? Your job as a DevOps engineer to create these containers for them and provide it to your developers. They will write whatever logic they want to write inside that container. And your job is to create this container and provide this container to your developers. Okay, so you will have 10 containers for checking credit card number, 10 containers for checking CVV, 10 containers for checking the balance, 10 containers for checking the amount, and 10 containers for giving you the feedback. So total how many containers will become? 60 containers. So minimum to minimum in real time, you will have 100 or 200 containers to manage. So your job is to create containers and provide it to your developers. And let me tell you one more thing, writing and executing the logic inside a container is challenging for developers. Because on virtual machine, they can write it easily, but to get executed inside a container, any logic, it's challenging for developers. But still they are trying, and every company, guys, they want to move it to container technology only. They want to containerize their application or software you have. Okay, so if I take a one more very popular example over here, okay, you have your, okay, food delivery apps, right? Okay, you have Swiggy or Zomato, or if you take Ola or Uber, they are working on containers. Like every company, they want to run their setup on containers only. That is why containers are becoming so much popular in the market, because they are using less CPU, less memory, means less costing for a company, but they are getting more speed, less failure rate, right? So what is happening with Swiggy and Zomato over here? If you take the same kind of containers over here as well, suppose this is your container 1, container 2, container 3, okay, and you have your container 4 and container 5, okay. So the first container will be searching for your order over here, right? It will check and it will search for order, it will search for the restaurants, right? And the second container, it will assign you the delivery guy, right? Next you will track the delivery guy, okay. This container will be tracking the delivery guy for you, okay. And the next container, you will be having a payment gateway, payment to be made, and then you have your feedback container, okay. So now whatever payment you have to do over here, right? Payments normally on your Swiggy and Zomato, if you observe, guys, they are linked with PhonePe and GPay over here, right? Okay, your payments gateway is mostly linked with your GPay and PhonePe over here. They are easily integrated over here. Why? Because they are running on containers. They are running on containers, and from container to container, if you want to establish connection through API, it is very smooth. You can easily integrate from one container to another container. So that is the reason you see you have easier options given for payment to be done using PhonePe and GPay. Because container communication is very smooth. From this container to those containers, you can easily communicate. right? Even for tracking, Swiggy or Zomato will not do any tracking over here. They will go and they will link to your Google container. Your Google will be doing, Google Maps will be doing all the tracking over here, right? So this Google Maps, it will be linked to that Google Maps container over here. So from over here, it will go to your Google Maps container, right? So talking about Google Maps, I got one more thing important. So have you ever seen any ads on your Google Maps, guys? The Google Maps which we are using. Okay, have you seen any ads on your Google Maps? So then what is the revenue for Google out of it? If they give it for free, like this to every one of us, they have to spend lots of money for that because they need huge setup for running maps, right? And they have thousands of teams who are working on maps only, specially. Forget about YouTube, Gmail, okay? They are having so many products to their list, right? Google News, okay? All those things are there. Google Weather is also there, okay? So if I talk about only maps, they don't give any ads when you see the maps, right? So then how they are getting the revenue, how they are getting the money out of maps? We are not paying anything for maps also, right? How they are getting money? So companies like Swiggy, Zomato, Uber, Ola will pay to Google Maps so that it will get integration with their app and you will be searching the delivery guy or you will be searching the cab. Okay. So companies like them, they will be paying to Google. Okay. I've just taken the names of 4 companies. So there are so many companies which needs Google Maps, guys, actually. Okay, if you see Rapido, they need Google Maps. Okay, so whichever tracking you have, tracking apps, they have to purchase Google Maps for their corporate use. So from those companies, Google will be getting the revenue, guys. They are generating the revenue for maps with the help of those companies. Even shipping companies which are there, huge shipping companies, they do the traveling, right? They still use Google Maps and they will be using paid maps. Okay, so from there it generates the revenue. Okay, we are the customers actually. The one which we are using, Google Maps, the free one, it is actually a testing one. We call it as a beta one. Okay, so normally whatever Google Maps you people are using, we are tracked. Okay, whatever settings you do, whatever privacy settings you add, still it will track you over there. With the tracking, it will improve its directions. With the tracking, it will improve its routes. So it is not charging anything from us, because from us it is getting the actual map. Okay, it is tracing all the routes with the help of the ones which we are using actually. Okay, so we are test users for Google. Okay, but their corporate maps which they are giving to different companies, okay, that is not a free version and that is not a tested version. Okay, after entire testing from our side, our mobile devices, then they give it to companies like this, and it's very costly for them, but still they have to use because they have to track delivery guys and all, right? So that is the reason they go for that. Okay, and they are getting billions of dollars so that they can provide it to us for free of cost. That revenue is enough for them. Okay, right? So you have Redbus, you have RTC, so many companies, they use Google Maps. Okay, cannot take the list, right? So now these containers actually helps you to communicate to another container very easily, guys. Okay, so that is why you have your payment gateways linked over there. Okay, now going forward, every company will be trying to run their app on containers only, guys. Okay, so it's a very huge challenge for developers. Okay, but still they are trying to containerize every application over here. It will take some time for the next 4 to 5 years. In the next 4 to 5 years, that is the reason why IT industry is booming, guys, right now. This is one of the reasons, because they are containerizing all their apps, right? Now what is our job? To create these containers and provide it to them, right? So now going forward, okay, let us create a sample container, guys, for our today's class. So first let me create our virtual machine. Okay, I will create a Linux virtual machine. You can create containers on Windows also, but it is not preferred actually. In real time, you will create it on Linux machines only. So I will create containers on Linux machine only over here as well. Okay, so let me first create one Linux machine quickly. Okay, I will call this machine as my Linux machine. Let me create this in my Asia region. Okay, so I'll be creating my Linux machine over here quickly. Let me select my Red Hat version 8, and I already have a key with me, right? So I'll use the existing key, my Linux machine, and let me quickly create this machine. Okay, and let me create, okay, at least one container for you guys. Okay, so first of all, anyhow, you understand the container architecture. Okay, so once you understand your container architecture, then we'll go ahead and then we'll create our containers anyhow. So let this virtual machine get ready over here, and then on top of this virtual machine, I will create containers. Okay, so deployment is in progress. So let this get created over here. Okay, so resource got created over here, guys. Now let me go to my Linux machine and let me log into my Linux machine. Okay, so I'll copy the IP address and let me open the terminal and let me increase the font. Okay, and to log into this machine, okay, I'll add my IP address over here and let me log into this Linux machine, guys. Yes, to connect. Okay, so the first thing which I will do over here is I will switch to root user over here by giving our sudo command, right? So as I told, whatever you are doing on your Linux machine, that will be your first command to enter, right? Now you want containers to get created, right? So if you want to create containers, we have to install Docker on your Linux machine. And to install Docker on your Linux machine, you will give yum space install space Docker and then -y, and Docker installation will start over here, guys. Okay, so now we can see the Docker installation has started over here. Okay, so Docker is getting installed, right? And once the Docker installation is complete, okay, if you go and check the service of Docker, as you know, Linux machine behavior, right? Whenever you install any package, if you go and check the status of your package, it will be in inactive mode over here, right? So now we have to start our Docker service. Okay, and then you have to enable your Docker service. Okay, so let us give some more time over here for it to get started. Okay, so now you can see, guys. Okay, it got started over here. Now if you check Docker images, first of all it will show you that how many images are there in your machine, and if you give Docker ps, okay, it should show you how many containers are there in your machine. Okay, so Docker PS will give you how many containers are there in your machine, and Docker images will show you how many images are there in your machine over here. Okay, so these are the two very important commands which you have to give mostly over here, guys. Okay, so Docker PS and Docker images. Okay, these are the two very important commands that using this, okay, you will be giving your, you will be checking your images and containers over here. Okay, so let it check. Okay, so from over here onwards we'll be doing a lot of Docker commands, guys. Okay, so Docker commands are very important for us, and using Docker commands, okay, we'll be working over here on our containers, guys. Okay, so if you want to work onto your containers, we'll be using Docker commands. Okay, so now you can check that I have, okay, got one image over here. So if you check Docker images, I got one Java image over here. Okay, similarly, if you want to get one more image, so the command to get the image is Docker pull, guys. If you write Docker pull, for example, if you want MySQL image, write MySQL. For example, if you want, okay, Python image, write Python. For example, if you want Java image, you can write Java over here. So whichever image you want over here, you can give that image name. But from where it is getting all those images? From Docker Hub. Okay, so once you give Docker pull command, it will go to Docker Hub and it will get that image for you. All your container images are in Docker Hub only. Okay, So you'll be getting that images from your Docker hub. Okay, for example, if I give Python over here, so it will be going and getting Python. Okay, so don't worry about this error over here. First it will search locally and then it will go to Docker hub and then it will get the image. Okay, so locally I don't have that image, right? So that is the reason it is downloading it from my Docker hub over here. Okay, now it is storing the image as well. So for creating the containers we need images, so that's why we are downloading the images from Docker hub over here, guys, and Docker pull is the command. Okay, so let it get downloaded over here. It is storing now. Okay, so now if you check Docker images, so how many images now you have over here, guys? We have two images over here now. Okay, one is our Java image and the other is your Python image over here, guys. Okay, right? So now using these images, okay, we'll be creating our containers. So if you check Docker PS over here right now, you don't have any containers being running over here, guys. Okay, now for creating the containers we can use the command as docker space run space -it hyphen name. Give your name to your container. Okay, I'll give a name to my container as Rajesh, for example. Okay, Rajesh is my container name, and if you want to use a Java image, use Java image, and to go inside this container we'll be writing /bin/bash to go inside this container. What is my container name? It is Rajesh, and I'm using a Java image over here for creating the container. Okay, and if you see over here, guys, once you give your container creating command and once you give enter over here, within a second it will create container for you over here. See, right now you are inside a container. The unique ID which you see over here, okay, this is your container ID. So once you give docker run command and you give enter over here, within a second container will get created for you, guys. Within a second it will be that much faster. And if you give ls over here and if you check, these are the files which are there inside your Java container. Okay, so these are the files which I have inside my Java container over here. So let me come out of this container. I will give exit and I will come back to my Linux machine. So I created a container, I went inside a container, right, and I'm back to my Linux machine. So let me create one more container over here, guys. Okay, so I'll say docker space run space -it hyphen name. Now I will call this container as Mohan container. Okay, I will use Python image this time. Earlier I have used the Java image. Now I will use a Python image, and to go inside this container, I will write /bin/bash to go inside that container. Okay, so if I give enter over here now, you will see that within a second, one more container got created over here. And if you check ls and see, these are the files which are related to my Python container. Okay, so now altogether, how many images are there? Let me give exit from over here and let me check. If you check docker space images, you can see that two images are there, Java image and Python image. And if you give docker space ps space -a, it will show you containers also over here. And how many containers are there? We have created two containers over here, guys. Okay, if you run docker space ps space -a, will show you over here. Okay, let me minimize this a bit more, so in this way you can clearly understand. This is your container ID. Okay, this is your container image. Okay, one is Python image, the other is Java image, and one container name is Mohan and the other container name is Rajesh. So using images, I have created my containers, and I have created this container about 40 seconds ago, and I created this container about 2 minutes ago. Okay, anyhow, there are a lot of things which we will be doing on these containers. Okay, there are a lot of things which we'll be doing. We'll be learning so many Docker commands. Okay, so first of all, install Docker on your machines and try to pull images and try to create some containers, guys. Okay, a few basic things only you have to do initially, and understand the Docker architecture, because if you understand the Docker architecture, will be very easy for us to understand the next things which we are going to do. Okay, right? So try to create some containers, pull some images, any image you pull, you just try to create, just have a hands on, and then we'll be going much deeper inside our containers. Execution ఈ కంటైనర్స్ అన్న ఎక్కడ ఉన్నాయి? VM లో ఉన్నాయి అంతే. కార్డ్ నంబరా? అచ్చా అచ్చా, ఆ ఎగ్జిక్యూషన్ అంటున్నారా? ఫస్ట్ ఆ కార్డ్ నంబర్, తర్వాత సివివి నంబర్, ఆ లాజిక్ అంతా రాసేది డెవలపర్స్. మన జాబ్ ఏంటంటే, ఇప్పుడు వాళ్ళు మీకు జావా కంటైనర్ క్రియేట్ చేయమని చెప్పారు, అప్పుడు మీరు ఏం చేస్తారు? ఈ కమాండ్ రన్ చేసి జావా కంటైనర్ క్రియేట్ చేసి వాళ్ళకి ఇస్తారు. వాళ్ళకి ఏది కావాలి? వాళ్ళకి ఈ కంటైనర్ ఐడి కావాలి. ఈ కంటైనర్ ఐడి వాళ్ళకి ఇస్తే వాళ్ళు కోడ్ వచ్చేసి ఆ కంటైనర్ ఐడిలో పుష్ చేస్తారు. సో ఆ కోడ్ వచ్చేసి మీ కంటైనర్లో ఎగ్జిక్యూట్ అవుతుంది. సో కోడ్ ఎగ్జిక్యూట్ అవ్వడానికి మనకు ఇంత పెద్ద వర్చువల్ మెషిన్ అవసరం లేదు, మనం చిన్న కంటైనర్తో రన్ చేయొచ్చు అంతే, ఇంకేం లేదు. ఓకే, నో దిస్ ఈస్ ద సెట్ అండ్ రైట్. ఎగ్జిక్యూషన్ ప్రాసెస్ మనం డిసైడ్ చేయాలి. ఓకే, సో మన జాబ్ ఏంటంటే కంటైనర్స్ క్రియేట్ చేయాలి, కంటైనర్స్ మేనేజ్ చేయాలి, right? So going forward, I will show you different methods of creating containers, different methods. Okay, so container commands, docker commands, okay, developers came out, developers doesn't know any docker command. Developer know how to write the code, in which order you want to execute, and they will push the code in that container id, that's it. Developer మీరు కంటైనర్ క్రియేట్ చేయమంటే డెవలపర్ కి డాకర్ కమాండ్స్ రావు, DevOps engineer కావాలి. Okay, right, fine. Okay, so I'll be saving the share for our today's class, so try to create your